I was walking through the grocery store yesterday doing the usual rounds. I spent, I don't know, 10 minutes picking out the perfect avocado, checking the firmness, making sure I wasn't buying a ticking time bomb of mush.
The avocado anxiety, I know it well.
It's the real thing. I grabbed the kale because, I feel guilty if I don't. I looked at the blueberries, debating if I wanted to take out a second mortgage to buy a pint. And then, as I was rounding the corner to the onions, I saw them.
Let me guess. The radishes.
The radishes. A little bunch of red spheres stuffed in a plastic bag, looking completely unremarkable. And it hit me. I have never, not once in my life, stopped to actually think about a radish.
Right.
To me, they're the garnish of the vegetable world. They're the thing you slice in and put on a salad so it looks like you tried. If I eat one, it's usually by accident or because I don't want to be rude to the chef.
You are definitely not alone in that. For most people, the radish is an afterthought. It's crunchy water with a bit of a bite. It's decoration. Yeah. Maybe you dip it in some ranch dressing if it's on a veggie tray at a party. But it's rarely the main event. It's never the star.
Exactly.
Yeah.
But then you sent me this stack of research earlier this week. And I have to say, of all the deep dives we've done, this one might be the biggest shock to my system. Because we aren't talking about eat your veggies because they have fiber.
No. Not at all.
We aren't talking about generic nutrition advice. We are talking about a root vegetable that seems to function like a hidden biological factory.
It really is a chemical factory, and I think that is the perfect mental model for today's deep dive. We are going to peel back the layers, or the skin, really, of this humble root.
Okay.
And we're going to find that inside, it is packing some serious pharmacological weaponry. It's not just food, it's information that your body reads and reacts to.
And just to set the expectations for everyone listening, we are filtering out the noise today.
Yeah.
Because if you Google radish benefits, you get a lot of folklore.
Oh, a ton of it.
You get, my grandmother said this cures a cold, or rub a radish on your knee for arthritis. We are not doing that.
Yeah. No folklore today. We are strictly, and I mean strictly, looking at high-quality human clinical trials. We're going to be dissecting the Evans study from 2014, which looks at the liver in a way I've rarely seen tested with a whole food. And we're looking at the Kajia study for 2025, which is brand new, cutting-edge research on vascular health. We will touch on some mouse data, but we'll be very clear when we do.
So we're going to answer some massive questions. Can a specific type of ugly black radish actually reprogram your liver enzymes to process toxins faster?
A key question.
Is there a literal monster radish grown in volcanic soil that helps blood vessels relax? And my personal favorite, the chemistry lesson I didn't know I needed. Why cooking a radish breaks it, and the mustard hack that fixes it.
That hack completely changed how I cook. It's one of those things that once you know, you can't unknow it. It feels like a secret.
Same here. It's practically a magic trick. But before we get to the kitchen chemistry, we have to start with the organ that I think takes the biggest beating in our modern lives.
The liver.
The liver.
The metabolic workhorse.
Right. And this brings us to the first star of our show, the Spanish black radish. Now, I've seen red radishes. I've seen white daikon. I have never seen a Spanish black radish.
Paint a picture for me. What are we looking at here?
Okay, so if you saw this in the produce aisle, you might honestly think it was a mistake.
Yeah.
Or that it went bad. It doesn't look appetizing at all.
Really?
It's about the size of a turnip, or maybe a large beet, maybe a bit rounder. It has this rough, coarse, matte black skin.
Yeah.
It literally looks like a lump of coal or a rock you'd dig up in the garden.
They're not the cute little red button radishes we buy in the spring.
No, it's the goth cousin of the radish family. It's intimidating.
Okay.
But the contrast is what makes it so striking. When you slice into that black, tough skin, the flesh inside is brilliant, snowy white.
Wow.
But the smell, it's pungent, it hits you. And the taste is not mild. It has a serious, peppery, almost horseradish-like bite. It clears the sinuses.
Which, in the plant world, usually is a warning sign or a signal of potency, right?
Yeah.
Sweet things are usually safe calories. Bitter or spicy things are usually medicine or poison. Precisely. That bite is the chemical signature of compounds called glucosinolates. It's the plant basically screaming, I am defending myself, don't eat me. And historically, this specific black radish, the scientific name is Raphanus sativus variety Niger, has been used for centuries in Unani, Grecian, and traditional Indian medicine. It was always prescribed for bilious conditions, issues with the gallbladder, the liver, digestion.
But tradition isn't proof. We've seen plenty of traditional remedies fall apart when you put them in a lab, and that's where the Evans et al. Study from 2014 comes in.
This is the one.
This paper blew my mind, not just because of the results, but because of how they designed the test. They used Tylenol.
They did. Acetaminophen.
Okay, explain that to me. Why are we giving healthy people Tylenol to test a vegetable? It sounds like a bad frat party prank. Here, eat this radish and take some painkillers.
It does sound counterintuitive, I get it. It seems like you're stressing the liver to test it. But in pharmacology, acetaminophen is what we call a probe drug.
A probe drug?
It's the perfect crash test dummy. We know exactly, down to the molecule, how a healthy human liver processes Tylenol. It's a completely known quantity. We know the pathways, we know the enzymes, and we know the timeline.
So it's a benchmark. It's the standard ruler against which you measure everything else.
Exactly. When you take Tylenol, your body has to get rid of it. It can't just stay in your blood forever. Your liver has a very specific set of enzymes that break it down, modify it, and package it for excretion in your urine.
Okay.
By measuring what shows up in the urine and what remains in the blood, researchers can see exactly how fast and how efficiently those enzyme systems are running. It's like sending a test car down a highway to check the speed limit and the flow of traffic.
Okay, that makes perfect sense. So who are the guinea pigs here? Who are the subjects of this test?
They took 20 healthy male subjects, and this is a really important point. These weren't sick patients with liver disease. They were guys with normal functioning livers.
Why is that so important?
Because we aren't trying to fix a disease here. We are seeing if we can optimize a healthy system. It's about enhancement, not just repair. It's a much higher bar to clear.
Got it. And they put them on a radish regimen.
A heavy one. They gave them a supplement containing freeze-dried Spanish black radish. The dose was equivalent to about 2.2 grams of the raw root per day.
Huh. 2.2 grams. That doesn't sound like a huge amount. That's like a teaspoon of powder, maybe less.
Well, the supplement was concentrated, so that's key. But in terms of fresh vegetable, think of it as eating a solid, medium-sized radish every single day. Not a massive salad, but a consistent therapeutic dose.
And they did this for how long?
For 4 weeks. And at the beginning and end of that 4-week period, they did the Tylenol challenge.
The Tylenol challenge. I like that.
Right. And to really appreciate what they found, we have to pause for a second and do a quick liver 101 because detox is a word that gets thrown around by influencers selling tea, and it usually means nothing.
Yeah, it's become a marketing term.
It has. But medically, detoxification is a very rigorous, very real two-step process.
Phase I and phase II. I read this in the notes, and I love the analogy you used. You compared it to taking out the trash. Let's break that down, because I think people visualize the liver as a filter, like a Brita filter that you just rinse out.
Right, like a screen for catching gunk.
But it's not a filter. It's a chemical processing plant.
It is absolutely a chemical plant. So imagine you have a bag of toxic trash in your kitchen. That's the Tylenol. Or a pesticide from your food, or alcohol, or even hormones your body is done with.
Okay.
Phase I detoxification is like bagging that trash up. Your liver enzymes, specifically a family called cytochrome P450, they attack the toxin and chemically modify it. They make it reactive. They essentially put a chemical handle on it so other enzymes can grab it.
Okay, so phase I is preparation. The trash is bagged. Simple enough.
Right. But here's the danger zone, and this is what people always forget. The product of phase I is often more toxic and more reactive than the original substance.
Wait, really?
Yeah.
More toxic.
Oh, yeah. It's like you've put leaking battery acid into a thin plastic bag. You cannot leave that sitting in the hallway of your cell. You have to get it out of the house immediately. If it sits there, it causes damage. It creates free radicals.
And that's where phase II comes in. That's the solution to the leaky bag.
Phase II is the disposal crew. This step is called conjugation. Another set of enzymes comes along, attaches a big, bulky, water-loving molecule like glutathione or sulfur or an amino acid to that reactive trash bag.
Okay.
This does two things. It neutralizes the reactivity, and it makes the whole package water-soluble. Once it's water-soluble, it can travel safely through the blood to the kidneys or into the bile, and you pee it or poop it out. That's taking the trash to the curb.
So you need a rhythm. You need a perfect tempo. Bag the trash, take it to the curb. Bag the trash, take it to the curb.
Exactly. You need them to be in sync. If phase I is super fast bagging trash like crazy, but phase II is slow and sluggish, you end up with a hallway full of leaking toxic sludge. That's oxidative stress. That's how liver damage can happen.
And that's why some of those like extreme detox juice cleanses can actually make you feel worse.
Yeah.
Because they might only be ramping up phase I without supporting phase II.
That's the theory, yes. You're creating a bottleneck. You're accelerating the problem without accelerating the solution.
Fascinating. So back to the study. The guys on the Spanish black radish. What happened to their trash removal service? Did it get out of sync?
It went into overdrive. But, and this is the absolutely crucial part, it was a balanced overdrive. Both phases sped up together.
Okay, show me the data.
First, let's look at phase 1. The level of unchanged acetaminophen in their blood plasma dropped by 40%.
40%. Wait, say that again?
A 4 narrow. 40%. It means that after 4 weeks of eating this radish extract, their liver was attacking the drug, it was bagging the trash, 40% faster than before.
That seems massive. That's not a small effect.
It is statistically huge. It means the phase I enzymes were upregulated significantly. They were clearing the initial substance at record speeds.
But did the disposal crew keep up? Or did they just pile up toxic sludge in the hallway like we were talking about?
That was the fear. That's what you'd worry about. But the data showed that phase 2 ramped up beautifully to match it. They found that mercapturate metabolites in the urine increased by 37%.
Okay, translate mercapturate for me. That sounds like a wizard spell.
It does, doesn't it? Mercapturate is simply the scientific name for the end product of that phase 2 process I mentioned. It's the Tylenol, after it's been attached to glutathione. It's the final, neutralized, ready for the toilet package.
So seeing more of that in the urine is proof that the trash actually made it to the curb.
It's the receipt. It proves that the body didn't just modify the toxin, it successfully neutralized it and cleared it out of the system.
So the Spanish black radish didn't just make the liver work faster, it made it work better. It increased the capacity of the entire engine, both the intake and the exhaust.
Correct. And I want to emphasize how rare this is. We see this kind of result in animal studies all the time. Oh, we fed this mouse some broccoli extract and its liver got better. Fine. But to see a 40% change in the pharmacokinetics of a probe drug in healthy human beings just by adding a vegetable supplement, that is profound.
It really is.
It suggests that our baseline liver function, what we consider normal, might actually be operating below its genetic potential. We're cruising in third gear, and this radish shifts us into fifth.
So what is the signal? What is the magic key inside the black radish that turns the key in the ignition of the liver?
The prime suspect and the focus of a lot of research is a compound called glucosinolates.
Glucosinolates, that's a mouthful.
It is. It's a specific type of glucosinolate. Now, all radishes have glucosinolates. It's what gives them their white. But Spanish black radish is unique. It has up to 4 times more of this specific type glucosinolates than your standard red radish or daikon.
So quantity matters. You can't just eat 4 times as much regular radish and expect the same result.
Not exactly. Quantity and quality both matter. It's the specific molecular structure. When you chew and digest glucosinolates, it breaks down into a bioactive molecule called rafisatin.
Okay.
This molecule, rafisatin, is the real worker. It gets absorbed, enters your liver cells, and literally travels to the nucleus of the cell. It flips the genetic switches.
Which switches?
Specifically a master switch called the NRF2 pathway.
NRF2.
Yeah.
We've heard that acronym before in deep dives on aging and longevity.
You have. NRF2 is often called the master regulator of antioxidant defense and detoxification. When rafisatin hits that switch, it tells the DNA in your cells, hey, we've got a challenge here. We need more enzymes, build more pumps. We need to clean house. It's the foreman walking onto the factory floor and screaming, double time, everyone.
A very effective foreman, apparently. And this really highlights why the variety of radish matters so much. If you ate the same weight of those little red radishes from the plastic bag, you probably wouldn't see this effect because the concentration of that specific payload just isn't there.
Exactly. You'd get some benefit, sure. All crucifers are good for you. But the black radish is the specialist. It's the heavy artillery for the liver.
That is just incredible. It makes you wonder what else our liver could do if we just gave it the right set of tools. But I want to pivot now. We've covered the liver, which is amazing. Let's talk about the heart, or more specifically, the blood vessels.
The plumbing.
The plumbing. Because you sent me stuff on a radish that sounds like it belongs in a Godzilla movie.
The Sakurajima daikon.
The monster radish. I'm not exaggerating. I looked up a picture of this thing. Listeners, if you are near a computer, Google Sakurajima daikon. It looks like a beach ball. It can weigh 30 kilograms.
Or more.
That is a 66-pound radish. My dog weighs less than that.
It's the world's largest radish variety. It's absolutely massive. It holds the Guinness World Record.
And it grows in volcanic soil. That sounds so mythical.
Yes. In the Kagoshima Prefecture in Japan, right near the base of the active Sakurajima volcano, the soil there is unique. It's very loose, full of ash and pumice. which allows this root to expand to these comical proportions without resistance from dense clay.
So for a long time, this was just a local curiosity, right? A prize-winning giant vegetable at the county fair. Look at the size of this thing.
Exactly. It was a novelty. But researchers, specifically in this Kajia study from 2025, so this is brand new cutting-edge stuff, started analyzing its chemical profile. They realized that while the black radish relies on those sulfur-smelling compounds we just talked about.
Glucosinolates?
Right. The Sakurajima has a different secret weapon, a compound called trigonelin.
Trigonellan. Now, I've heard of this. Isn't this in coffee?
It is. It's an alkaloid, a niacin analog, which means it's related to vitamin B3. It's found in coffee beans and fenugreek seeds. But usually, root vegetables aren't the place you look for it.
But this one is different.
This one is completely different. The Sakurajima radish is packed with it. We are talking about approximately 60 times more trigonelin than a common Japanese radish, a standard daikon.
60 times 6.
60 times. That's not a rounding error. That's not a small variation. That's a completely different food profile. It's a chemical anomaly created by the unique genetics of the plant and its environment.
Wow. And the researchers wanted to know, does this massive dose of trigonelin actually do anything for the human cardiovascular system?
That was the exact question. Does this translate from a chemical curiosity into a real physiological effect in people?
So they set up another human trial.
Just smaller one this time. 14 healthy adults. And the test here wasn't Tylenol. It was something called FMD, flow-mediated dilation.
I'm going to need you to unpack that one for me.
Sure.
Flow-mediated dilation. What are they actually measuring with that?
Think of your arteries like a garden hose, but not a hard plastic one. A flexible, living rubber hose. If you turn up the water pressure like when you stand up to exercise or get stressed, the hose needs to expand to let that extra blood flow through without the pressure skyrocketing. That ability of the vessel to widen on demand is called vasodilation.
So a stiff hose is bad. A flexible hose is good.
Stiff is terrible. Stiff, rigid blood vessels are the hallmark of aging, of atherosclerosis, and high blood pressure. You want that flexibility, that dilation. FMD measures exactly that.
How do they do it?
They put a blood pressure cuff on your arm and they squeeze it tight to completely cut off the blood flow for a few minutes, which is pretty uncomfortable. Your arm goes numb.
I've had that done. It's not fun.
No, it's not. Then they release the cuff and whoosh, the blood rushes back into the forearm. They use a very sensitive ultrasound machine to watch the brachial artery in your upper arm. A healthy artery will sense that rush of blood and will widen significantly in response. An unhealthy, stiff one will just sit there, rigid.
So they measure the participants' hose flexibility at the start.
They got a baseline, yes. Then they fed them the monster radish.
What was the dose?
The participants ate 170 grams of raw Sakurajima radish per day for just 10 days.
170 grams. That's manageable. That's 6 ounces, like a decent-sized side salad.
Very manageable. And after just 10 days, they did the FMD test again. The results were striking. The average FMD score went from 6.7% to 9.4%.
Okay, help me with the scale here. A 2.7 percentage point increase. Is that a lot? It sounds small. If I got a 2.7% raise at work, I wouldn't be throwing a party.
Fair point.
Ugh.
But in the context of vascular health, that is clinically meaningful. It's a big deal. An FMD below 7% is often considered at risk or suboptimal. Getting up near 10% is considered excellent, optimal.
So it moved them a whole category.
Yes. It effectively moved the average participant from a normal but could be better range into an optimal athletic range of endothelial function. And remember, these were healthy people to start with.
Right.
Improving function in a healthy system is hard to do. It's much easier to fix a broken car than it is to make a brand new Ferrari go faster. They made a healthy system healthier.
That's a great analogy. And do we know how? What's the mechanism? Is the trigonelline just relaxing the vessel directly?
It seems to work by stimulating the production of a very famous molecule, nitric oxide, NO.
Nitric oxide, the pump molecule.
Yeah.
Bodybuilders take supplements for this to get bigger pumps in the gym.
They do. Arginine, citrulline, all those are aimed at boosting NO. Nitric oxide is a gas that acts as a signaling molecule. It's produced by the endothelium, the single-cell thick lining of your blood vessels.
Okay.
It's the signal that tells the smooth muscle cells wrapped around the artery, relax, open up, let more blood through.
So how does the radish compound trigger that?
The study showed that trigonelin enters the blood, they confirmed it gets absorbed, it's bioavailable, and it activates specific receptors on those endothelial cells. This triggers a release of calcium inside the cell, which in turn kicks an enzyme called ENOS endothelial nitric oxide synthase into high gear.
So the radish provides the key, the trigonelline, that unlocks the nitric oxide factory already built into our blood vessels.
That is a perfect way to put it. You're just giving the factory foreman the orders to start production. And here is a practical bonus from the Sakurajima study that I think is huge for people at home.
Okay.
We talked about how the black radish compounds, the glucosinolates, are fragile and sensitive to heat.
Right, they break when you cook them.
But trigonelline, it is tough. It is remarkably heat stable.
It's stable, so you can cook it.
Very stable. The study specifically tested this. They showed that trigonelline survives boiling for up to 10 minutes, and it survives frying. You can simmer this giant radish in a stew, you can roast it, you can stir-fry it, and the trigonelline stays intact.
That is a huge distinction because, as we'll get to in a minute, cooking is usually the enemy of radish potency. But for the Sakurajima, you can cook it and still get the heart benefits.
Yes. It makes it a much more versatile vegetable for this specific purpose, for vascular health. You don't have to punish yourself with a raw, spicy root if you don't want to. You can enjoy it in a warm soup.
So, quick recap. We have the liver specialist, which is the Spanish black radish.
Right.
We have the vascular specialist, the Sakurajima daikon.
The giant.
The giant. Now I want to address the elephant in the room. Or rather, the elephant on the internet. Diabetes.
Ah, yes. The internet loves a cure-all.
If I type radish into a search bar, the first autocomplete suggestion is radish diabetes cure. There are a million articles saying radishes lower blood sugar. What does the actual deep dive say? Are we seeing the same level of evidence as these first two studies?
This is where we have to pump the brakes. Hard. The enthusiasm online vastly outpaces the clinical evidence in humans.
But where's all the hype coming from?
Rats.
It's always the rats.
It is almost always the rats. Look, in diabetic rat models, radish extract lowers blood sugar beautifully. It works great. But humans are not 70-kilogram rats. Our metabolism is infinitely more complex. The human evidence we do have is what I would call very low quality compared to the Evans liver study or the Vascular study.
So no big randomized controlled trials.
Not on raw radish for diabetes, no. We don't have large, rigorous trials proving it lowers your HbA1c over the long term. It's mostly speculation based on the rat data and some test tube studies.
So in the notes, you did find a glimmer of hope, a little spark, but it wasn't about the raw radish. It was about fermented radish.
Yes, this is where the story shifts from the plant itself to the process of fermentation. There was a study by Park et al. In 2019 using kakdugi.
Kakdugi, that's the cubed radish kimchi. I love that stuff. It's crunchy, it's spicy, it's sour, it's fantastic.
It's delicious. And it might just be metabolic magic. In this study, they took pre-diabetic participants, so people whose blood sugar is starting to creep up into the danger zone, and they gave them 150 grams of kakdugi with a meal.
Standard rice-based meal.
A standard high-carb meal, yes. And they measured their blood sugar response.
What did they find?
They found that eating the kimchi reduced the post-meal glucose spike, what we call the area under the curve, by about 16%.
16% is real. That's not nothing. That's the difference between a sleepy afternoon slump and staying alert and focused. But why? Is it the radish or is it the fermentation process?
It's likely the synergy of both. First, you have the basic effect of the fiber from the radish, which is going to slow down digestion and sugar absorption a bit. That's simple.
Okay.
But the fermentation is where it gets interesting. Fermentation creates postbiotics. The bacteria consume the sugars in the radish, and in the process, they produce brand new compounds that weren't there to begin with. Things like organic acids and GABA.
GABA, as in gamma-aminobutyric acid. Isn't that the neurotransmitter for anxiety and calm?
It is the main inhibitory neurotransmitter, yes. It tells your brain to chill out. But it also plays a role in your peripheral tissues, in glucose metabolism and insulin sensitivity. It's not just for the brain. Plus, fermentation turns the radish into what we call a synbiotic. You have the prebiotic fiber from the radish, which is food for your gut bugs, and you have the probiotic bacteria from the fermentation culture. The fiber houses the bacteria, helping them survive the journey through your stomach acid.
So the bacteria are upgrading the radish. They're processing it for you before you even eat it, creating new beneficial compounds.
Exactly. And there was another piece of data, a massive cohort study. This is observational, so we have to be careful not to confuse correlation with causation. But it looked at over 115,000 Koreans.
115,000 people. That's a small city. That's a good sample size.
A very good sample size. They tracked their dietary habits and their health outcomes, and they found that men and women who regularly ate radish kimchi had an 8% to 11% lower risk of abdominal obesity.
The spare tire around the midsection. The dangerous kind of fat.
Right, the visceral fat that surrounds the organs. And while we can't say eating kimchi caused the weight loss definitively from this tapas study, the signal is strong enough to suggest that including fermented radish in the diet is metabolically favorable. It's certainly better than having a side of French fries with your meal.
So let me just summarize where we are. If I'm optimizing for blood sugar regulation and maybe even body composition, the arrow points to fermented radish.
That's where the best human evidence is right now.
For the liver, it's raw Spanish black radish.
Yes.
For the heart and blood vessels, it's the giant Sakurajima, raw or cooked.
You're seeing the pattern. Radish isn't just one thing. The variety and the preparation dictate the benefit you get.
And that brings us to what I think is the most critical, practical part of this whole deep dive, the mustard hack. You teased this earlier. Why do we need a hack? What is so wrong with just boiling a regular radish?
This is the tragedy of cruciferous vegetables, and it applies to broccoli, kale, cabbage, all of them. To understand it, we have to look at what I call the bomb biology of the plant.
Bomb biology. I like the sound of that. It's dramatic.
It's the best way to describe it. Think of a single cell in a radish root, or a broccoli florets, or a kale leaf. The plant doesn't want to be eaten. It wants to defend itself from pests, so it builds a chemical weapon.
Okay.
But it can't keep the weapon armed and active all the time, or it would poison itself. It would die, so it keeps the ingredients separate and stable.
Like a two-part epoxy.
That's a perfect analogy. In one compartment of the cell, it stores the payload, the glucosinolates, like that glucoraphasatin we talked about.
Okay, the payload.
In a totally separate compartment, it stores the fuse, an enzyme called Myrosinase.
So as long as the cell wall is intact, the payload and the fuse never touch. Nothing happens. It's safe.
Right. But when a caterpillar bites into the leaf, or when you chop the radish with a knife, or, crucially, when you chew it with your teeth, the cell walls break. The payload mixes with the fuse. Boom!
You get a chemical reaction.
You get an instant chemical explosion. And the product of that explosion is a class of compounds called isothiocyanates, ITCs. These are things like rafisatin from the radish or sulforaphane from broccoli.
And these are the spicy, pungent molecules.
Exactly. These are the things that burn the caterpillar's mouth and make it go away. But for us, these ITCs are the medicine. They are the things that trigger the NRF2 pathway, that upregulate the liver enzymes, and that have all these protective effects.
So you need the explosion. The explosion is the whole point.
We need the explosion. If there is no explosion, there is no medicine. But here's the problem, and it's a big one. The enzyme, the fuse, myrosinase, is extremely sensitive to heat. It dies. It gets denatured at about 60 degrees Celsius or 140 degrees Fahrenheit.
140 Fahrenheit. That's nothing. That's not even a simmer. That's a hot bath. My coffee is hotter than that.
Exactly. So imagine you take a whole radish or a whole broccoli floret and you throw it in a pot of boiling water. Or you put it on a sheet pan to roast in a 400-degree oven. The heat penetrates the tissue and it kills the enzyme before it has a chance to mix with the glucosinolates. The cell walls are still intact, and you cook the fuse dead in its own compartment.
You disarm the bomb.
You permanently disarm it. You are eating the payload. The glucosinolates are heat stable, they survive, but the fuse is dead. You chew the cooked radish, and nothing happens. The potential medicine just passes through your body, largely inactive.
That is heartbreaking.
Yeah.
All those times I roasted radishes or boiled broccoli, I was just eating fiber and some vitamins.
You were getting fiber and some vitamins and minerals, which is not nothing.
Yeah.
But the potent genetic switching ITCs, the real heavy hitters, data suggests you lose 50% to 70%, maybe even more, of the potential benefit.
Okay, so give me the solution. Obviously, eating it raw works because the enzyme is alive and you do the mixing when you chew.
Eating raw is the gold standard for these compounds. That's why the Evans liver study used a raw extract equivalent. But let's be honest, chewing on a raw Spanish black radish is intense. It's spicy. Not everyone is going to do that every day.
All right, so if I want to cook it, if I want to make roasted radishes, how do I save the medicine?
This is the mustard hack. It is brilliant in its simplicity. If you cook your radishes, you have killed the native enzyme. But remember, the glucosinolates, the payload, are still sitting there intact, waiting for a spark.
They just need a new fuse.
You need a fuse, exactly. So after you cook the dish and let it cool slightly, just so it's not boiling hot and you don't kill the new enzyme, you sprinkle on some raw mustard seed powder.
Why mustard specifically?
Mustard is a cousin of the radish. It is also a cruciferous plant. And mustard seeds are absolutely packed with a very durable, very potent form of the myrosinase enzyme. By adding the raw mustard powder, you are reintroducing the fuse to the cooked payload.
So the reaction happens right there in the bowl or in your stomach.
Both. In the bowl, as you mix it, and then it continues in your stomach, you are artificially reactivating the chemical explosion that the cooking process destroyed.
That is just, it's so clever.
It is, and studies on broccoli have shown that adding just a pinch of mustard powder can restore the bioavailability of sulforaphane almost to the level of eating it raw. It's a complete game changer.
And it's so cheap, it's just mustard powder from the spice aisle.
It's pennies, and it
Yeah.
doesn't even have to taste like mustard. You just need a tiny pinch. Or, if you don't have mustard powder, you can chop up a little bit of a raw daikon or raw arugula or even a bit of horseradish and mix it into the cooked dish. As long as you introduce some live enzyme from a raw cruciferous vegetable, you ignite the reaction.
I love that. It's like a cheat code for nutrition, reviving the dead vegetable.
It really is. And one more quick tip on potency, which we touched on, chewing.
Chewing. How important is it, really?
It's critical. Remember, the whole reaction relies on breaking cell walls. If you are one of those people who just inhales their food, chews twice, and swallows a big chunk, you are leaving a lot of medicine locked inside intact cells, even if the radish is raw. If the cell doesn't break, the fuse doesn't hit the payload. You have to chew thoroughly, almost to a pulp, to maximize the potency. It's mechanical chemistry.
So chew your food, kids. It's not just manners. It's biochemistry. Now, before we wrap up, we absolutely have to talk about safety. Because whenever something is potent enough to change liver physiology by 40%, it's usually potent enough to cause trouble if you aren't careful.
Absolutely. Food is powerful, and bio-individuality matters. We can't pretend one size fits all. Potency is a double-edged sword.
So who needs to be careful with radishes, particularly the potent black radish?
There is one very specific group that needs to be extremely cautious with the Spanish black radish: people with active gallstones.
Why? I thought you said it was good for the gallbladder, that it helps with bilious conditions.
It is good for preventing stagnation. See, Spanish black radish is a choleretic, which means it makes the liver produce more bile. And it is a cholagogue, which means it makes the gallbladder contract and squeeze that bile out. If your gallbladder is just a bit sluggish and the bile is thick, that squeezing action is great. It's like a flush for the system.
But if there's a stone, a physical obstruction.
If there's a stone blocking the exit, blocking the bile duct, and you take a supplement that makes the gallbladder squeeze hard, think about what's happening. You are squeezing a muscular balloon against a rock. That is a recipe for disaster.
Ouch.
It can cause severe colic, intense pain, or in a worst-case scenario, even a rupture of the gallbladder.
Okay, so if you have a known obstruction, or suspect you might, do not start chugging black radish juice.
Exactly. Consult your doctor. If you have active gallstones, steer clear until they are resolved.
But what about the thyroid? This is a big one for cruciferous veggies. I always hear people say, don't eat radishes or broccoli if you have thyroid issues.
That is the goitrogen fear. And there is a kernel of truth to it, but it often lacks nuance. Radishes do contain compounds that can, in high enough doses, interfere with iodine uptake in the thyroid gland. However, the clinical data and context shows this is generally only a risk if two conditions are met at the same time. One, you have a pre-existing iodine deficiency, and two, you are eating massive, unrealistic amounts of the vegetable raw.
So if I'm eating a normal diet with adequate iodine from salt or seafood, and I have radish salad a few times a week, it's not going to shut down my thyroid.
Highly, highly unlikely. And interestingly, cooking destroys most of the goitrogenic compounds. But remember, cooking also destroys the medicinal ITCs we want. So it's a trade-off. For most people with normal iodine intake, moderate raw consumption is perfectly safe.
Good to know. One last safety check. Medication interactions. You mentioned the liver study showed the radish-induced or sped-up enzymes. Does that mess with prescription drugs?
It certainly can, and this is really a sign of its potency, not a flaw. Because it speeds up those cytochrome P450 enzymes, it could theoretically speed up the metabolism of any drug that is processed by those same enzymes.
Like what?
Common examples are drugs like warfarin, which is a blood thinner, or theophylline, an asthma medication.
So if it speeds up the metabolism, the drug leaves your body faster than the doctor intended.
Exactly. It could lower the concentration of the drug in your blood, making it less effective. Or in some rare cases, if a drug needs to be metabolized to become active, it might make it too effective too quickly. The bottom line is, if you are on a crucial medication with a narrow therapeutic window, meaning the dose has to be precise, you should definitely tell your doctor before you start a rigorous Spanish black radish regimen.
It's funny, we treat these things as just food, But if it can change your liver physiology, it's just logical that it can change your drug metabolism too.
Food is biochemical information. We can't forget that. We aren't just putting fuel in a tank. We are putting code into a computer.
So let's bring this all together. We've covered a lot of ground. The radish is not just crunchy water.
Far from it. It's a specialized tool if you know which one to pick.
So if I want to do some spring cleaning for my liver to really support those detox pathways, what's the protocol?
The evidence points directly to Spanish black radish, ideally raw, grated into a salad with some olive oil and lemon to cut that intense spice. The Evans study used an equivalent of about 1 solid serving of the fresh root daily for a few weeks. That's the protocol that's proven to upregulate those phase 1 and phase 2 enzymes.
And if I'm more worried about my blood pressure or my vascular health, if I want that flexible garden hose.
Saccharojima daikon is the champion there, thanks to its sky-high levels of trigonelline. But since we can't all fly to Japan to get the volcanic giant, standard daikon also has some, and eating it raw or cooked, since trigonelline is stable, can contribute to nitric oxide production.
And if I'm looking for metabolic support, for blood sugar balance?
Fermented radish, kimchi, kakdugi, that's where the human data is. Get those postbiotics and the symbiotic effect working for your gut microbiome.
And the golden rule for cooking almost any of them except the giant one for heart health.
The mustard hack. Never eat a cooked crucifer without adding a pinch of raw life back into it via mustard powder or some raw greens. Don't waste the medicine you paid for.
I love that. It empowers you to actually get the benefit of the food you're buying. It completely changes the way you look at the produce aisle. It makes you realize that everything there has a purpose if you just know how to use it.
Absolutely. It's about respecting the chemistry of the food.
You know, this whole deep dive has really shifted my thinking. We look for pharmaceutical solutions for everything. And don't get me wrong, modern medicine is a miracle. But here we have a common root vegetable that can literally alter the genetic expression of our primary detoxification enzymes within 4 weeks.
It is remarkable. It's a reminder that nature has had a few billion years of R&D time to figure this stuff out.
It leaves me with a final thought for our listeners. If the humble radish, the thing we ignore on the side of the plate, the garnish, is capable of flipping genetic switches, inducing enzyme production, and relaxing blood vessels, what else in that produce aisle are we completely underestimating? What other complex biochemical information are we just chewing and swallowing without realizing the incredible power of what we're eating?
That is the question, isn't it? The grocery store is a pharmacy if you know what to look for and how to read the labels.
I think I'm going to go buy some black radishes and a tin of mustard powder.
Enjoy the burn. It means it's working.
Thanks for joining us on The Deep Dive. We'll see you next time.